Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at National College of Ireland, and this short video, another video in our series of videos dealing with coordinate geometry, and in particular coordinate geometry of the line, is going to present a derivation of the distance formula, or more importantly the formula that allows us to calculate the distance between 2 points, okay, in two-dimensional space. Okay, so what we'd like to do is we'd like to be able to calculate the distance between 2 points and a rationale behind where the formula comes. But just let's recall that we do have an important term. Let's just recall Pythagoras. Okay, Pythagoras. Okay, the Pythagorean theorem. Okay. The Pythagorean theorem for right angle triangle. Okay, theorem for a right angled triangle. Okay, just recall that. Okay, we have a right angled triangle. Okay, so we have some triangle. Here it is here. Okay, let's say that the points here are A, B, and C. Okay, say for argument's sake, okay, that these vertices of this triangle are A, B, and C. This length here, okay, is the length between the line segment AB. Okay, this length here is the length of the line segment AC, and this length here is the length of the line segment BC. Okay, and this is a right angled here. Okay, so what we know from Pythagoras' theorem is that actually, I suppose this is the hypotenuse over here. We could say, okay, this is the hypotenuse. Okay, this is the opposite angle here, and here's the adjacent. Okay, so let's just say this is the opposite angle, opposite of this particular angle here, the angle BAC, and this is, I suppose, let's say our adjacent. So we could just actually, from that perspective, call this the adjacent angle. So what we have from Pythagoras is that the square of the hypotenuse, okay, that's the square that we can construct on this particular thing, that the area of that particular square, okay, which would be h times h, is the same as the sum of the areas of the squares of the opposite two sides. So it's the square that can be created here and the square that can be created here. So Pythagoras basically tells us that h squared is equal to O squared, okay, plus A squared in this case, yeah. Okay. Or more importantly, from a line segment perspective, it's the length AB to be squared is the same as the length BC to be squared plus the length AC to be squared. Okay, that's the Pythagorean theorem. It allows us to calculate the length of the hypotenuse, or the length of any particular side in a right angle triangle, given any piece of information. Given two pieces of information, the two other sides, we can always find the third side. Okay, so let's consider this. Let's take this now into coordinate geometry, okay, and in particular try to calculate the distance between 2 points. Okay, so let's say, for argument's sake, okay, let's say that we're given, okay, so let us say, okay, that we are given 2 points. Let's call the first one A. Okay, that has coordinates x1, y1. Okay, and the next one B that has coordinates x2, y2. So let's say that we are given 2 points A and B. Okay, and what we want to calculate, and we wish to calculate the distance, okay, between the points A and B. And more importantly, we want to develop a formula. Okay, we want to develop a formula, okay, that will allow us to do this particular calculation. Okay, so let's just take the points A and B, and let's just plot them in two space, or let's plot them in the Cartesian coordinate system. Okay, so let's take our 2 points A and B. So we have, let's just say for argument's sake, that we have an x-axis and that we have a y-axis. Okay, so let's say that we have an x-axis along here. Okay, so this is our x-axis, and we have some other axis along here, which is, let's say, which is our y-axis. And let's say that this point here, where the x-axis and the y-axis intersect, okay, that this point here is the origin, and these are perpendicular to each other. Okay, and we have 2 points. We have the point A and we have the point B. Okay, let's say the point A is here somewhere. Okay, and let's say for argument's sake that the point B is up here somewhere, okay? Without loss of generality, we can put them points wherever we want to put them, okay? But we'll just build the argument from this particular perspective. Now don't forget the point A. The point A has coordinates x1, y1. So the point A, okay, can be located. It's a distance of x1 away from the origin in the x direction, and it's a distance, I suppose, it's a distance of y1 away from the origin in the y direction. Okay? That's the coordinates x1, y1 for the point A. And similarly, the point B, well, the point B is a bit of a distance away. It's a distance of x2, okay, away from the origin in the x direction, and it's a distance of y2, okay.